Lesson 9-8 Special Products, and in this lesson you learn to use patterns to find the quantity A plus B squared, the quantity A minus B squared, and the quantity A plus B times the quantity A minus B. So why is it important? Because you can use polynomials to solve problems involving biology and history. Let's take a look at this biology connection. Punnett squares are diagrams that are used to show possible ways that genes can combine fertilization. We studied this last year in seventh grade, talking about Mendelian genetics. So in a Punnett square, dominant genes are shown with capital letters. Recessive genes are shown with lowercase letters. Letters representing the parent's genes are placed on two of the outer sides of the Punnett squares. Inside the boxes of the square show the possible gene combinations of their offspring. Okay, the Punnett square below, which we're going to go to in a little while, uh, represents a cross between tall pea plants and short pea plants, and we let T represent the dominant gene for tallness. Okay, and let lowercase t represent the recessive d for shortness. Okay, so the parents are called hybrids since they have one of each kind of gene. Remember last year we called this heterozygous genes because they're not true breeding. Okay, so this is the Punnett square that we're talking about right here. Okay, they're hybrid tall because it's not a true breeding tall plant. And then at the same time, you have a capital T and lowercase t, a dominant and a recessive gene. So we are basically getting the product of a hybrid tall times a hybrid tall pea plant. Okay. So again, tall represents capital T, short represents lowercase t. And if you look at our Punnett square, capital T times capital T give you two capital T's. Capital T and lowercase t give you a capital T lowercase t. Capital T lowercase t will give you a capital T lowercase t. And two lowercase t's will give you a product of two lowercase t's as well. Okay, so the offspring, if we list the offspring, 1/4 or 25% of pure tall because there's 1 out of 4. Okay, and then 2/4 or 50% of hybrid tall because of these two, and finally 1/4 or 25% pure short. Remember, this was Mendel's second generation experiment. Okay, so because the parent plants have both the dominant tall gene and the recessive short gene, biologists know that their offspring can be predicted by squaring the binomial 0.5 t plus 0.5 lowercase t squared. Therefore, the following must be true if you are multiplying 0.5 capital T plus 0.5 lowercase t squared. Okay. This is equal to basically 0.5 capital T plus 0.5 lowercase t times 0.5 capital T plus 0.5 lowercase t. So using the FOIL method or the distributive property, okay, we now have 0.5t times 0.5t, okay, 0.5t times 0.5 lowercase t, okay, 0.5 lowercase t plus 0.5 capital T, and 0.5 lowercase t times 0.5 lowercase t. And simplifying this further, we have 0.25 capital T squared, 0.25 capital T lowercase t, 0.25 capital T lowercase t, and 0.25 lowercase t squared. Adding the like terms, we now have 0.25 capital T squared plus 0.5 capital T lowercase t plus 0.25 lowercase t squared. Okay, and remember that capital T squared will represent TT, two capital T's, and lower t squared will represent two lowercase t's respectively. Okay, so if you notice, okay, we just use the Punnett square to multiply binomials. Okay? So, let's move on. You can use the diagram below to derive a general form of expression of a plus b in parentheses squared. So remember, when you're talking about uh, uh, multiplication of polynomials, you're basically multiplying them so that you get the length and the width, and then you get a rectangle or a square. Okay, and since this is quantity a plus b squared, okay, it simply indicates that you're going to end up with a square. Okay, where one side is a plus b and the other side is a plus b as well. And if we draw it out, look what's going to happen. You have your a and b on the horizontal and vertical uh, sides of our polynomial mat or our algebra tile mat. And the area of the green tile will be a squared, because one side is a, the other side is b. And if you look at our two light blue squares, there are two of them. Okay, because when you have a times b, that will give you that ab, and this a times that b will give you area of ab as well. And finally, the small square at the bottom will be lowercase b times lowercase b. That will be b times b. Okay, so if we look at our model right there, a plus b squared in parentheses is actually equal to a squared plus ab plus b squared. Simplifying that further, it will be equal to a squared plus 2ab plus b squared. Okay, and if you want to check this, use the FOIL method to find out that they have the same, that they're going to come out, you're going to come out with the same result. So in general, what we're saying is that the square of a binomial, that is the sum, can be found by using the following rule. So basically what we have here, okay, is a pattern that we will use to create the square of a sum. So the square of a sum simply states that if you have a quantity a plus b squared, it is equal to a plus b times a plus b, or a squared plus 2ab plus b squared. Now this becomes very important because in chapter 10, once we go to factoring, okay, we call this a perfect square trinomial, but it's going to be the opposite. You're going to be transforming this trinomial into that form. Okay, so just remember this now and understand this, because later on this becomes very instrumental and significant when we go on to factoring. So find each product. Y plus quantity y plus 7 squared. Method 1, we are going to use the square of a sum rule. Okay, so if we use square of a sum rule, we now have the pattern a squared plus 2ab plus b squared. So, okay, so we want to find out what a is and want to find out what b is, and simply follow this pattern. So we have a is equal to y and b is equal to 7 right there, and we simply substitute the values to our trinomial right here. So y squared plus 2 times y plus 7 squared. And if we want to simplify this is simply a y squared plus 14y plus 49. Okay, and if you use the FOIL method, you'll end up with the same answer, because y plus 7 squared will be y plus 7 times y plus 7 using the FOIL method would be equal to y squared plus 7y plus 7y plus 49, or y squared plus 14y plus 49. And let's take a look at example B, 1b. Okay, 6p plus 11q in parentheses squared. Again, we use the method 1, okay, the square of a sum rule, where quantity a plus b squared is equal to a squared plus 2ab plus b squared. Okay, memorize this, because this is going to be very useful even when you get to high school. Okay, so we want to find out what a is and what b is, and if you notice, our a is 6p and our b is 11q. So we simply substitute the values. So now I have quantity 6p plus 11q squared is equal to 6p, quantity 6p squared plus 2 times 6p plus 11q plus 11q squared. We simply substituted the values for a and b, where a is 6p and b is 11q. Okay, simplifying this further, we have 36p squared plus 132pq plus 121q squared. Okay, move on to example 2. Not that one, this one. The square of a sum rule can be used with other rules to simplify products of polynomials. And let's read this word problem. Tourists, okay, of the southern part of England can visit the historic Gwena Pit. I think that's how you pronounce it. In the 16th century, the pit of a tin mine was discovered into an amphitheater. During the 18th century, John Wesley spoke to overflow crowds in this amphitheater. The Gwena Pit consists of a circular stage surrounded by circular levels for seating. Each seating level is 1 meter wide. Suppose the radius of the stage is s meters. Okay, find the area of the third seating level. Okay, so this is a word problem where we can we can apply what we learned in terms of square of a sum. Okay, so we start off with the amphitheater. Okay, and it says there that the radius of the stage is s meters. There you go. Okay, find the area of the third seating level. So if this is s meters, okay, this would be s plus 2, the radius, and the third would be s plus 3. Okay, so the area of the circle, of course, is pi r squared. The radius of the second seating level is s plus 2 meters, and the radius of the third seating level is s plus 3. Okay, so the area of the third seating level can be found by subtracting the areas of the two circles. Okay, so basically, this is what happens when you have the area of the third level, which is pi times r plus 3 squared, because that's the radius, and this is the formula for area. And we are going to subtract the area of the second level, which is pi times quantity s plus 2 squared, which is the radius of the second level. Okay, and if we simplify this further using the sum of a square rule, this becomes now pi times s squared plus 6s plus 9. Remember that in this case, our a, remember we're doing this rule right over here. So a plus b squared is the same as a squared plus 2ab plus b squared. So this is our a. Our a is s in this case, and our b is 3 for the third level. Okay, so this becomes now s squared plus 6s. Why is it a 6s? Because you talk about 2ab, and 2ab is 2 times s times 3, and 2 times 3 is 6, and that's the reason why you have 6s. 9 simply is because it's 3 squared. So we do the same to the area of the second level. Now becomes pi times s squared plus 4s plus 4, again using the square of a sum rule. And simplifying this further, meaning to distribute the pi to both expressions, pi s squared plus 6 pi s plus 9s, pi s squared plus 4 pi s plus 4 pi, and then we distribute the negative one. This negative one will be distributed right here. Okay, so let's use this. This is a negative one, which you will distribute to all three terms. Okay, and that's how you end up with pi s squared plus 6 pi s plus 9 pi minus pi s squared minus 4 pi s minus 4 pi. And then we simply add our like terms, combine our like terms. We now have 2 pi s plus 5 pi. So the area of the third seating level is 2 pi s plus 5 pi. And then we substitute pi with the approximate, its approximate value. It would be 6.3s plus 15.7 square meters. Okay, and that is for that example. And let's move on to the next important square. This is now called the square of a difference. But before we do that, let's take a look at this one. To find the quantity a minus b squared, we write quantity a minus b plus a plus negative b and squared. Remember the definition of subtraction. In the definition of subtraction, you simply say that when a is minus b, is the same as a plus negative b. This is the definition of subtraction. So we basically convert that and we simply square it. So you now have a minus b, same as a plus negative b squared. And then we square it using the using the square of a sum rule. And this becomes now a squared plus 2 times a minus b plus negative b squared, or the same as a squared minus 2ab plus b squared. Okay, and if you use the FOIL method, that's exactly what we're going to get. Okay, so first a times a is a squared, outer a times negative b will be negative ab, and then inner, this is also negative ab. Okay, and last would be negative b squared. So if you notice, it comes out the same whether we use the sum of the square of a sum or the FOIL method. So in general, the square of a binomial, that is the difference, can be found by this by using the following rule. Now take a look at this one. A minus b quantity squared is the same as a squared minus 2ab plus b squared. Remember the sum, the square of a sum rule. In the square of the sum rule, it's something like this. So the square of a sum rule is just simply a plus b squared is equal to a squared plus 2ab plus b squared. In the square of a difference, look what happens. There is a minor change now. Well, not minor really. Instead of adding, you are subtracting. Okay? So the square of a sum and the square of a difference is very much related to each other. You simply change the sign of the second term of the trinomial. Okay? So let's look at example number 3 and see how this works. We have the quantity r minus 6 squared. Method 1, we use the square of a difference rule. Okay, so in square of a difference, we find out what our a is and what our b is. Our a is r, our b is 6. So we have a quantity a minus b squared is equal to a squared minus 2ab plus b squared. Substitute the values a and b to that, and now have r minus 6 squared is equal to r squared minus 2 times r times 6 plus 6 squared. You end up with r squared minus 12r plus 36. Okay, so that's how you find the product, by just looking at the pattern. Method 2 is if you use the FOIL method, it is basically the same thing. Okay, first outer, inner, last. Okay, and then you still end up with r squared minus 12r plus 36. And example 3b, again same thing. We use that rule now. Okay, and we find out what our a is. Our a is 4x squared and our t is 7t. Okay, so in this case, our a is equal to 4x squared and our b is equal to 7t. And we simply substitute those values, okay, by first writing out the square of a difference rule right here, and then substitute a and b to where it's appropriate. And there you have it, 4x squared minus 7t squared, or quantity squared. Okay, we substitute that a to become 4x squared squared, 2 times 4x squared plus times 7t plus 7t squared. Simplify that, end up with 16x to the fourth minus 56x squared t plus 49t squared. Okay? And let's take a look at one more rule, okay, which is going to be, again, very instrumental in the next chapter when we do factoring. Okay? But before we do that, let's take a look at this one using the FOIL method. Sorry, that one. You can use the FOIL method to find the product of a sum and a difference. So remember, our first one is product of a sum rule. Sorry, square of a sum rule. Second rule that we learned would be the square of a difference rule. Okay, and this one now is a difference of squares. Okay, now if you notice, it's a combination of the addition and the subtraction. Okay, for a square of a sum and square of a difference, we call this the difference of squares. Now, the difference of squares right here will not change when we start factoring. It'll still be called the difference of squares. Okay, so this again very important. And if you use the FOIL method for quantity a plus b times quantity a minus b, first, outer, inner, last, this is what we're going to get. We have a times a, which is our first. Outer will be a times negative b, inner will be b times a, and last would be b times negative b. Simplifying that, you now have a squared minus ab plus ab minus b squared. And if you notice, these two is equivalent to 0. So you end up with a squared minus b squared. Okay, so the resulting product has a special name. It's called the difference of squares. Now, the reason why we're using all these rules is because it saves you time when you know what the rule is. You don't have to do the FOIL method. All you need to do is follow the pattern. So the difference of squares rule simply states that if you have the quantity a plus b times the quantity a minus b, okay, it is the same as a squared minus b squared. You simply find your a, find your b, and square both of them. Okay, let's take a look at example number 4 and see how this works. Before we do that, the secret word for this lesson would be pistons. The secret word for this lesson would be pistons. Okay, so the quantity m minus 2n times the quantity m plus 2n. So in this case, we follow our rule and we simply identify our a and identify our b and follow this pattern right here. So we want to follow this pattern using our a and our b. And now we have m squared minus 2n squared because our a is m and our b is 2n. And if we simplify that, it simply is m squared plus, or sorry, m squared minus 4n squared. Okay? And let's make this a little bit more complicated by using decimals. And in decimals, now we have 0.3t plus 0.25w squared times the quantity 0.3t minus 0.25w squared. Okay, identify our a and b using the difference of squares rule. Our a is 0.3t, our b is 0.25w squared, so simply substitute the values. Now, we have 0.3t squared minus 0.25w squared squared. Okay, using our rules of exponents, now we have 0.09t squared minus 0.0625w to the fourth. And it makes it a lot easier compared to if you're going to multiply these two binomials. You're going to use the FOIL method or you're going to use the distributive property method. But if you know the difference of squares rule, all you need to do is follow the pattern and you're done. Okay? And that's the end of our lesson. Thank you for watching.